So the final bit that is missing in our installation is Calculix, which is a finite element program that was developed by MTU Aero Engines for the simulation of their gas turbines. It is similar to Abaqus in use, but it does not have a modern graphical user interface. The website looks very much like it is out of the 1990s, which is correct for the website, but not for the code, which is very much a modern FEA code with all the necessary features and all the modern features. We will follow the precise instructions for installation of the Calculix and the Calculix adapter. So if you go to the docs here, the documentation is very well set out for precise provided adapters. Calculix, then we need to go through these steps that are outlined here. So we need to get Calculix and download Calculix first. So we will install a few dependencies. And luckily for us, in Ubuntu-based systems, all we need to do is copy this one line into our terminal, which will install the libraries that are used. So dependencies here, all we need to do is copy this in here. That will run an installation again and will install all the necessary libraries. And then we need to build Calculix with the precise adapter. So we go into our home directory, we download the Calculix version that we want. So we copy this, but don't hit enter yet when you copied that command. We want to go to the part where it says version and tell it that we want version 2.16. You can click this link, which is the README for the adapter, which will tell you which version this adapter was written for. This adapter was developed for Calculix version 2.16, so that's why we downloaded that version. And then we need to unpack this in tar file. Tar is something similar to zip, but for Unix systems. So we unpack this using the command tar with X for extract, V for verbose, tell us what you're doing, file, read the file that I tell you, and J, it is a BZ2 compression on that file. Very often you will find a GZ compression here, in which case you replace the J with a Z. So that has unpacked that. And the next step is continue to the page, get the adapter. So on this page, it tells us how we can get that adapter. Download and unzip the adapter, for example, in the Calculix folder. Okay, let's do that. We need to go into the Calculix folder for that. Okay, my computer is getting slow again with video processing and everything. And then all we need to do is copy these three commands. We can even copy all three commands in one go. That should work. So this did download it with wget, downloaded it from the internet, it unzipped that zip file, and it changed into, with cd, change directory, we changed into the directory of the adapter. And we don't, on Ubuntu systems, you don't need to do anything with editing the make file, etc., which could be a bit tricky. So if you are installing this on Ubuntu 20.04, then everything will work out of the box. On a Pop! OS system, we need to change one thing, which may feel a bit daunting, but let me just go to another screen here and show you what we're going to do. We go to the Calculix folder, we go into Calculix Adapter Master, and we will simply open a text editor with this makefile. This is a file that tells the compiler how to compile the code. So this is the file where you can break quite a lot. And it's this line 64 here, which in 65 has the note, oops, sorry. This file 64 is the one that we need to change. And in line 65, it tells us what we need to change. For the GNU C compiler version 10 or newer, we need to add this into this line above. So we just enter F, allow argument mismatch, and then we save that file and close the editor. That's all we need to do here. And then we can go back and in this Calculix Adapter Master, simply issue this command. If you have tried it to build it before, you can say make clean, but if not, you simply say make, or if you have more than one CPUs, and we didn't do that before when we compiled programs, we can use more than one CPU. I only gave this 2 CPUs, so I only do make -J2 because my virtual machine only has 2 CPUs. And then I execute that. There's going to be a lot of warnings because of the modern compiler being complaining about some old style Fortran code, but it is nonetheless perfectly fine. It's just that the Fortran code is a bit old-fashioned and some of the constructs are not used, and there are quite a few variables which are not used, and the compiler complains about that. But that is not a problem. The code runs quite nicely despite the warnings. So this will take some time again. So I'll pause the video here. I'll stop the video here. I'll pause the video here and just check in to see if everything worked well, and to run the first test of our complete installation with all the with both codes and the FSI coupling library, and then we'll see if everything worked out. We can run the tutorial case as a test, and then we are set up for our project. Okay, this compilation finished without problems. So the next step would be to test the installation, and Precise comes with quite a few tutorial cases. So if we can get this system working again. So let's set up in our home directory, let's create a new folder Precise, in which we can set up the tutorials, and the tutorials can be copied from Git again. So let me change into this Precise folder here. Okay, computers. One tip when you run a virtual machine, make it full screen and don't, oops, I already changed into that CD. Precise, and don't work between two operating systems at the same time. The computer will always try to switch between the two, and then these lags occur that you are witnessing in this video, because I'm switching between the video recording software and the virtual machine. So this Precise folder now needs to get these tutorials. So give me this, all of it, copy it in here. So that will copy the tutorial files. And if we go to the Precise folder, we now see the tutorial files. The tutorial files are set up in a way that makes it relatively difficult to really see what is happening there. So for the time now, we are just going to use one to see if everything is working. So we're making a copy of it, because I usually like to keep the tutorial files intact. So let's just make a copy of this. Hello, are you going to make a copy of this now? Well, let's make a copy of this in the terminal. So we are here now. Yeah, a copy we can make with CP -A for all, or you can also use -R for recursive, which works equally well. And then ElasticTube 1D is the one that I want to copy, and I want to copy it into ElasticTube 1D test. I then go into that ElasticTube 1D test file directory, which we see here. Come on, open that. And you see fluid. Okay, that is not. Ah, no, that's the wrong case. My apologies. I want to do the ElasticTube 3D, which has OpenFOAM and Calculix in it. So cd change, not comma, dot, and copy a ElasticTube 3D to ElasticTube 3D test. Come on. And then change into ElasticTube 3D test. So in here, we now have an OpenFOAM directory. We have a Calculix directory. And we have a configuration file for Precise, which we're going to have a look at all of that in more detail later on. So for this video, I only want to check if everything is working. So what we need to do, we need to run two files here. We need to run the two run script files in the OpenFOAM directory, fluid OpenFOAM. Here's a run.sh And in the solid Calculix, we have a run.sh, which we need to run. So I need a second terminal. So new window here. Let me run OpenFOAM in this one. So OpenFOAM to 106 to initialize OpenFOAM. So that is done. And oh, I forgot one thing that we need to set up. And that is we need to copy our Calculix, or we need to link our Calculix into the right new folder, sorry. We need to give me a second window here. We have Calculix adapter master bin, and in here we have one file which we need to put somewhere where we can find it. And that is now a little bit of a tricky thing. We have CCX precise, which is our folder that we need. And we want to copy that into, or link that into a directory which we have access to, or where the system will look for executables. So you may have heard of the path variable in Windows. We need to do something that puts CCX precise into the path. So let's go into our home directory, cd. Okay, we need to exit out of this. Control D exits out of a shell. So we now can go, oops, what's happening here? cd. Okay, here it works. Something was wrong with that terminal. So cd here, and then we should have a .local, which is a hidden file, and a bin directory there. So we change into that, and then we create a symbolic link, ln -s and then what we want to link, namely tilde, which is our home directory, Calculix adapter master, bin CCX _ precise. And that we want to link into the local directory. So, and we now see that that has been created here. Yeah? And if we do ls for list -l for long list, then we see, oops, we don't see, because I can't scroll. Again, little lag while the computer is pushing data from one system to the other. We see here in that list, we should now up there, yeah. We see that this CCX precise is a link to this CCX precise. So, and local bin should be in the path. Well, it is not. No, it is not. So we now need to go to our home directory and edit one file, which is the system of our, the configuration of our shell, and we need to add the path there. So we can take Control H and we can go here, and that shows us all, Control H shows all the hidden files here, and the bash RC is the one that we want. So open with text editor, and that text editor, we just go to the bottom here and add one line in which we write export. Let me zoom in a bit. Oh, can I not zoom here? No, this doesn't allow me to zoom apparently. Okay, what I want to enter here is export path equals $path $home /local/bin. Then I save that and I close that text editor. I close that terminal. I open a new terminal. Need to close this one as well. I open a new terminal, and now I should find CCX Precise. So that has now set up everything, and we can test our installation. So for that, we need two terminals. We need to go to Calculix, no, to Precise, CD Precise, CD Tutorials, Elastic Tube 3D Test. And in this side, we want to run the Fluid version, the Fluid code. So that's this. And here we change to CD Precise, Tutorials. And the tab key does the auto completion. So I can now type EL and then tab. When I get Elastic Tube, I type 3. I get Elastic Tube 3D. I type minus tab and I get Elastic Tube 3D Test. I then can type sol tab and get solid Calculix. So in this side, we need to initialize OpenFOAM. On this side, we can simply run the solid solver. The solid solver will start and then wait for the fluid solver. So setting up master communication decoupling partners. So it's waiting for the partner, and that is here, OpenFOAM. So if I run the run.sh in here, then that will do the solid fluids calculation, and you see how both are now calculating and they're talking to each other. And this shows us that the simulation is indeed working. So let me pause the video here or stop the video here, and I'll be back with a video showing you what the outcome of this test simulation is.